You know D-Day, the biggest amphibious invasion in history. But let me ask you this. How did that massive army get the millions of gallons of gasoline they needed the very next week into France? Tankers were being sunk. There were no ports. The answer: British engineers secretly laid an oil pipeline right under the English Channel. It was called Project Pluto. And what about the U-boats? They were sinking everything in the Atlantic because their communication was unbreakable. The answer: Alan Turing and his team built the world's first colossal computers. Their goal wasn't just to crack a code, but to instantly change the entire course of the war. They beat the Enigma machine with its own weapons. This war wasn't won just with bullets. It was won with tonnage. When the Germans were sinking a ship, what did American industry do? They built an entirely new cargo vessel in just 4 days and 15 hours. Yes, you heard that right. The Liberty ships. And carrying all that war machinery across muddy terrain was a standardized miracle. The Jeep. Today, we focus on the unsung geniuses of the war. We reveal 5 unbelievable engineering secrets, created by people whose names you might not know, but whose inventions saved millions of lives and single-handedly won World War II. These forgotten stories also reveal how modern technology was born. Let's jump right in. The problem. Imagine you've just fought your way onto the beaches of Normandy. You've established a foothold. Now, you need tanks, trucks, and aircraft to push into Europe. What's the one thing that all of these machines need to move? Fuel. The logistical nightmare. Getting millions of gallons of gasoline from Britain across the English Channel and into Nazi-occupied France was a logistical nightmare. Shipping fuel in oil tankers was slow, dangerous, and a prime target for German U-boats. Lose one tanker, and your entire armored advance stalls. The solution: Project Pluto. Enter the British engineering team. Their idea? Forget the tankers. Let's just run a pipeline under the ocean. The project was nicknamed Pluto, which stood for Pipeline Under the Ocean. How it worked: visual focus, technical drawings, and maps. This wasn't some huge steel pipe. That would be impossible to lay quickly. They used a specially designed, flexible pipe, kind of like a heavy-duty garden hose, that could be spooled onto massive floating drums the size of a ship. The unveiling. They laid this flexible pipe, known as HIS, standing for the 2 main engineers, Hartley and Isaacs, across the Channel bed. They started on the Isle of Wight and ran it straight into Cherbourg, France. It was a secret operation from start to finish. The test. They had to pump the fuel across 70 miles, 113 kilometers, of rough water. The initial results were slow, but by the time the Allies broke out of Normandy and started the race across France, Pluto was operational. The impact. Pluto ultimately delivered over 172 million gallons, 780 million liters, of fuel to the Allied forces. Think about that number. That's enough fuel to keep the entire Allied invasion machine running non-stop. The outcome: General Patton's lightning-fast advance across France, the one that broke the back of the German defenses, was entirely dependent on this unseen underwater lifeline. This pipeline, this engineering marvel, was literally the artery of the liberation of Europe. It's still considered one of the most successful, most audacious military engineering feats in history. Transition. Pluto gave the Allies the fuel, but they still needed a port. And that brings us to secret number 2. The challenge. The D-Day invasion was massive. Millions of men, millions of tons of equipment. The plan was to seize a major French port like Cherbourg. But the Germans knew that too. They fortified Cherbourg heavily, and when they retreated, they demolished the port facilities completely. The strategic crisis. You can't land an entire army without a proper port to offload supplies. The invasion was stalled until the engineers stepped in with a crazy idea. If the enemy won't give us a port, we'll bring our own. The solution: Mulberry Harbours, visual focus, construction and assembly. The Allies built 2 enormous, fully functional, prefabricated artificial harbors in Britain and towed them across the Channel. These weren't just piers. They were full ports complete with breakwaters, roads, and piers, capable of handling cargo ships. Key components: Phoenix caissons, massive concrete blocks, some the size of a 5-story building, sunk to form the breakwaters. Bombardins, floating steel breakwaters designed to create a calm sea area. Whales, floating roadway sections connected by universal joints to handle the massive tidal range. The D-Day install. Within days of D-Day, the Allies towed these massive, multi-ton components across the Channel and assembled them off the coast of Normandy. It was like building 2 enormous Lego cities in the middle of a war zone. The storm test. One of the harbors, Mulberry A, was destroyed by a massive storm just days after installation. But Mulberry B, codenamed Port Winston, survived. The impact. Port Winston alone became the busiest port in the world, transferring 2.5 million men, 500,000 vehicles, and 4 million tons of supplies onto the continent. Before Cherbourg was operational, the entire invasion relied on this artificial port. The outcome: without the Mulberry Harbours, the Allied forces would have been unable to sustain their push into France during the critical early weeks. The entire invasion could have been reversed by a German counterattack simply due to lack of supplies. This was the ultimate victory of engineering logistics over enemy defenses. Transition. Supplying the troops was one thing, but figuring out where to send them was another. That meant breaking the enemy's communication. The bomb machine, cracking the uncrackable Enigma, approx. 6 o'clock, the War of Codes. By 1940, the Germans were winning the war at sea, primarily because of the Enigma machine. This machine generated a code that was mathematically near impossible to crack. It allowed German U-boats to communicate freely and sink Allied supply ships faster than they could be built. The problem: the British were losing the Battle of the Atlantic. They desperately needed to know where the U-boats were going next. This was a war of mathematics, not muscle. The solution: Alan Turing and the Bombe. Visual focus. Bletchley Park and machine diagrams. Enter the eccentric, brilliant mathematician, Alan Turing, and his team at Bletchley Park. Turing realized that the only way to beat the German machine was with an even better machine. They developed the Bombe. How it worked: the Enigma had billions of possible settings. A Bombe was an electromechanical device, a gigantic, noisy array of spinning rotors, designed to mechanically test all those possible settings much faster than any human could. It didn't break the code automatically, but it drastically narrowed down the possibilities. The process: every day, the codebreakers at Bletchley Park would run the latest intercepted German messages through the bombs. When a machine found a hit, it would signal a possible Enigma setting, and human operators would take over to decipher the day's messages. The impact: Bletchley Park employed nearly 10,000 people, most of them women working in complete secrecy. Their work reduced the length of the Battle of the Atlantic by months, potentially years. The outcome: the stats. Historians estimate that the intelligence gained by cracking the Enigma, code codenamed Ultra, shortened the war in Europe by at least 2 years and saved millions of lives. The aftermath: Turing's work, which formed the foundation of modern computer science, was kept secret for decades. After the war, his invention was destroyed to maintain secrecy. He was tragically persecuted for his personal life, a story we know too well, but his genius literally saved the world. Transition. While Turing was fighting the Code War, another group of engineers was fighting the production war. The crisis. The U-boats were sinking Allied cargo ships at an alarming rate, sometimes dozens a week. The Allies were losing the ability to transport food, resources, and weapons to Britain and the Soviet Union. The problem wasn't a shortage of ships. It was a shortage of time. The demand. Franklin D. Roosevelt needed a cargo ship that could be built faster than the Germans could sink them. The solution had to be simple, rugged, and above all, fast to produce. The solution: The Liberty Ship, visual focus, shipyards and assembly lines. American industrial genius rose to the challenge. They designed the Liberty Ship, a simple, standardized, no-frills cargo vessel. Henry J. Kaiser's factory. Shipbuilder Henry J. Kaiser perfected the assembly line for shipbuilding. Instead of slowly building the ship's hull from the keel up, his teams built massive sections, like bow sections, engine rooms, and sterns simultaneously in different parts of the yard. The revolution, welding versus rivets. Crucially, the Liberty ships were welded, not riveted. Riveting was slow and labor-intensive. Welding allowed for faster construction, though it caused some initial problems with the hulls cracking in cold weather. The speed record. Kaiser's yards became legendary. The record for building a single Liberty ship, from laying the keel to launch, was an unbelievable 4 days, 15 hours, and 29 minutes. The numbers. Over the course of the war, the U.S. produced 2,710 Liberty ships. They were cheap, ugly, and slow, but they were the workhorses of the Allied war effort. They carried 75% of all the cargo needed for the war. The outcome? The sheer volume of Liberty ships overwhelmed the German U-boat offensive. It didn't matter if the Germans sank 5 ships a week. The Americans were launching 10. This industrial capacity, this pure logistical superiority, was the decisive factor in the Battle of the Atlantic. It proved that mass production could defeat dedicated sinking. Transition. Mass production worked for ships, but it also worked for the small stuff, the items every soldier needed. The military needs. The U.S. Army needed a single, standardized, reliable, light, 4-wheel drive reconnaissance vehicle. It had to be rugged, simple to maintain, and capable of traveling anywhere. Before the war, every Army vehicle was bespoke and complicated. The solution? The Jeep. Visual focus, iconic images, and versatility. The answer came from a collaboration between Bantam, Willys Overland, and Ford. They created the GP General Purpose Vehicle, which quickly became known by its phonetic abbreviation, the Jeep. Design philosophy. The Jeep was the definition of form following function. No doors, a collapsible windscreen, simple canvas seats, and 4-wheel drive. General Eisenhower famously called it one of the 3 tools that won the war, alongside the airplane and the U-boat. Versatility. The Jeep wasn't just a transport vehicle. It was a machine gun mount, an ambulance, a radio car, and even a small tractor. Soldiers found endless ways to adapt the simple, sturdy chassis. The standardization factor. The key wasn't just the design. It was standardization. Every Jeep, whether made by Willys or Ford, was identical. This meant that a Jeep damaged in North Africa could use a part from a broken-down Jeep in Italy. Logistics became simple, fast, and efficient. The numbers. By the end of the war, over 640,000 Jeeps had been produced. They became the iconic symbol of American mobility and ingenuity. The global impact. The Jeep was perhaps the most enduring piece of engineering from the war. It didn't just win the war. It fundamentally changed how we design utility vehicles, leading directly to the SUV and off-road vehicles we see today. It taught the world the value of standardized, simple, reliable design. Transition. These 5 projects, the pipeline, the artificial harbor, the code-breaking machine, the mass-produced ship, and the standardized vehicle all proved one thing. Summary. World War II was a war of resources, time, and ingenuity. Hitler had brilliant soldiers, but he was ultimately defeated by better engineers and superior logistics. The real heroes, the true heroes, were always the ones holding the rifle. They were the ones laying the pipe under the channel, building a port overnight, sitting in a cold room, figuring out the daily settings for the bomb, and perfecting the welding technique for the next fleet of Liberty ships. The legacy. Every time you see a shipping container, every time you use a standardized part, Every time you hear about a supercomputer, you are seeing the direct legacy of these wartime engineering marvels. They weren't just wartime fixes. They were leaps forward for all of humanity. Final question. Which of these incredible secrets do you think was the most critical to the Allied victory? Pluto, the Mulberry Harbours, or the bomb? Let me know in the comments below. CTA. If you appreciate uncovering the real history behind the headlines, hit that subscribe button and join us next time as we dive into another forgotten story that changed the world. Thanks for watching.